All right, today we want to look at types of errors. So last time we talked about debugging and what debugging is, and that's looking for errors. And so we want to talk about the kinds of errors that can creep into programs when you write programs, because errors are inevitable, unfortunately. So we can divide types of errors into three different categories: syntax errors, runtime errors, and semantic errors. So syntax errors arise when whatever statement you type doesn't follow the syntax of the language. Okay, so computer programs, they have to follow a strict syntax, which just means syntax just means some well-defined structure that you have. And Python or any other language says exactly what a statement is supposed to look like. And if you don't make your statement look exactly the way that a correct statement looks, then the compiler can't recognize that as an actual real Python programming statement. Okay, so a syntax error will be any aspect of the code that doesn't conform to the syntax of the programming language. Okay, and these would be detected by the compiler when the program is compiled. So remember, we talked about the Python interpreter. Actually, when you look at the implementation of the Python interpreter, it goes through a compile stage. Okay, and so that compile stage, when it goes through that, it will tell you if you have made any syntax errors. So that's actually kind of nice that the compiler finds those kinds of errors for you, and so they're relatively easy to fix because the compiler will tell you there's a syntax error on this line, and you can look at it and go, oh, I forgot. My classic is I always forget the colon. Okay, so you can look at that line and go, oh, I forgot a colon there. All right, so that is syntax errors. A runtime error, on the other hand, okay, will not be detected until the program is running. Okay, so the compiler will find syntax errors before even one statement of your program is run. Okay, so the program won't be running at all when you find the syntax errors. Okay, a runtime error, the compiler went through, didn't find any syntax errors, it begins to run the program, and the program is running, and then all of a sudden it crashes. So something unexpected happened. Sometimes we call these exceptions. And so something that can't be handled by the computer has happened when the program is running. This is a runtime error. We'll look at an example in a second, but that's what a runtime error is. And then semantic errors, these are the trickiest ones to find because the compiler can't find them, your program doesn't crash, okay? And so a semantic error is really an error in the way that you designed the program, like you solved the program, the solution to whatever you were trying to do incorrectly. So there's an error in your logic and the way that you try to solve the program. So your program runs, but then it does something and it doesn't do what you expected to do. It doesn't actually do what you were trying to do. Okay, so if you think about the example program that I run for you with a guessing game, so let's say, you tell the user, I'm thinking of a number between 1 and 100, guess it. And then the person puts in 172, and you say, yes, that is correct. Well, they didn't put in a number between 172, and you told them it was correct. You didn't really do what you wanted to do. The program doesn't crash. It does something. It just doesn't do what you wanted it to do. So that would be like a semantic error. Okay. So first of all, let's look at these and something that you're probably very familiar with. You've probably encountered these when using a calculator. Okay. So let me grab my calculator here, and we'll look at, oops, let me clear those out. We'll look at some examples. So we'll start with this one here. Like, let's say I go into my calculator and I type 1 point divided by 2. And then I hit enter. So notice what it tells me. Error, syntax. I've got a syntax error. So even calculators have a well-defined syntax that they expect, and if your statements that you put into your calculator don't conform to what the language that it understands, which is like normal math language, then it will tell you that doesn't conform to a normally written math statement. Okay, so that will give you a syntax error. If I do this next one right here, this 2 divided by 0, and hit enter, I get an error again, but notice it doesn't say error syntax, it says something different. Okay, so this isn't syntax error. Like the syntax of a division statement is a number, then a division sign, and then another number. Okay, if that 0 that I typed in had been anything else, if it had been 2 or 4 or -7, it would have been fine with it. The only reason that it has a problem with it is because there's a 0 there. Okay, so it's not a syntax error. It is a different kind of error. Okay, if you do something like this in a program, you won't detect it until the program is running. It will become a runtime error. Okay, and then this last one is one that I see often with math students. So let's say you're doing a problem and you need to do 6, choose 4. Okay, and if you need to use the definition of how to do that using the formula for 6 choose 4, you would do 6 factorial over 4 factorial times 2 factorial. And then students will go to put that into their calculator. And they'll go, okay, well, I need to do 6 factorial over 4 factorial, 2 factorial. So they'll do 6 factorial over 4 factorial times 2 factorial. And they'll get 60. And they'll put 60. Okay. Now, 60 is not the value of 6 choose 4. So if we went into our calculator and I did 6, and I just chose this one, the 6 choose 4, the notation for that, and let it use its own formula instead of me trying to do it by definition, it tells me it's 15. Okay, so notice that when I use the definition of factorial, I got 60, and when I used like its definition of factorial, we got 15. Well, what's the problem? Like this should really be 15. Okay, well, I made a semantic error when I entered my formula. So I forgot that the calculator always uses order of operations. And so what it will do when I put this in is it will do 6 factorial divided by 4 factorial. It'll take that quotient and then it will multiply it by 2 factorial. That's not what I wanted it to do. That's not what I meant for it to do. But when I wrote that statement in there, that's what it will do because your calculator follows order of operations. Okay, this kind of thing will happen in Python as well. If you type this into Python, it's going to follow order of operations just like a calculator does. Okay, so you have to be very careful, and these are a little bit trickier to find because your program won't crash. It'll run, but then it'll just give you these bad values, and you'll be like, why is this number wrong? Well, it could be because how would I fix this semantic error? Well, what I really need is I need to change the order of operations, right? I want the numbers in the denominator to be multiplied first before the division happens. But in normal order of operations, we always do division and multiplication left to right. So the only way for me to fix this is to put some well-placed parentheses. So if I were to take this and insert some parentheses here, then I would get the correct answer, 6 factorial divided by, to make sure that that multiplication is done before the division, and I will get the correct answer. Okay, so that's that's an example of a semantic error, and you may have made semantic errors with your calculator before. Okay, so that should give you an idea of the kinds of errors that you will see in Python. Let's go ahead and do these with the Python interpreter as well and see what kind of messages we would get. So if I go to the Python interpreter and I type in 1 dot divided by 2, that's interesting. So notice here that Python doesn't give us a syntax error. This 1 dot divided by 2 is something that Python actually understands. Okay, so one thing to be careful about is the syntax of your calculator and the syntax of Python is not always exactly the same. So just because your calculator can't do something doesn't mean that Python can't do it. And just because Python, and just because your calculator can do something doesn't necessarily mean that Python can. So we'll just have to learn what sort of the differences between math operations in Python and math operations on your calculator. So just to let you know, this double division bar is an operator that Python defines, and it knows what it is. And we'll talk about that later, but that's why Python can do it. Your calculator does not define a double division operator, so it has no idea what that means, but Python does. Let's see what happens. Let me show you what a syntax error would look like. Let's just say I did, instead, let's do 3 question mark 2. Okay, so this one, notice it says syntax error, invalid syntax. So, and there's a leave-in pointing to it. I don't know what this question mark in between these numbers means. What are you talking about? Okay, so that's an example of a syntax error. It'll even point you to the right spot to show you where you've made the syntax error. So they tend to be pretty easy to fix. Okay, let's try this one, this division by 0. So if I do 2 divided by 0, okay. So notice it did not give me syntax error. That was not the message. It was 0 division error, division by 0, similar to what your calculator did. Okay, so this would be more of like this will make your program crash, and you'll just get this error message, and that would be an example of a runtime error. And then let's try this one as well. Let's say we did 6 factorial divided by 4 factorial, 2 factorial. Okay, so notice here we actually get a syntax error. So Python doesn't understand this exclamation point. Okay, so there is no exclamation point means factorial operator in Python. So this one actually just gives us a syntax error. So again, just because you can put something in your calculator doesn't necessarily mean that you can also put the same thing into Python. So you'll have to learn or how to, if you want to do a factorial, there's going to have to be some other way to do it other than that. Okay. So hopefully that gives you a good overview of the different kinds of errors that will arise. We'll do a lot more with errors and looking at error messages and fixing them as we go along, but just, to give you, something to expect, so when you start working in Python, you'll kind of recognize the different kinds of error messages and how to fix them. Okay, so when you do debugging, that's the process of finding and correcting errors in a computer program. As we mentioned, the compilation process will detect the syntax errors, and so those are usually the easiest kind to fix, because there's like a little caret pointing to where the error was, and you just have to say, oh, I forgot this, or oh, I forgot, it doesn't recognize, that's not an operator in Python, or whatever. So those will be pretty easy to fix. The compiler finds them for you, and you just fix them. The runtime errors are a little bit trickier, because you have to do some rigorous testing, often with some unexpected kind of input values to reveal runtime errors. So just because the program runs correctly once doesn't mean that it's going to run correctly every single time, because you might have some issues that you didn't think about. And so they can be a little bit difficult to detect, but usually once you once you make a runtime error, then it's usually not that hard to correct it. So let me give you an example. So remember we had this guessing game program. So let's say I want to run that program. Okay, so I run it. So welcome to Dr. Ganad's number guessing game. I'm thinking of a number between 1 and 100 of inclusive. Can you guess it? Okay, so like something that you might not think about is you think I told the person to put in a number between 1 and 100 inclusive. And so clearly they're going to obey what I asked them to do and do that. And they would never think of putting in the letter Q instead, or would they? Okay, so this is something unexpected. The user that's using your program isn't following directions, okay, and it crashes. And so notice it gives me this kind of crazy message. File tells me what, okay, on line 9, when I did this, there was a value error, an invalid literal for int with base 10, Q. Okay, so you'll get used to these messages. Basically, this int, it was expecting an integer. I told it to put it in integer, and I put in the letter Q, which is not an integer. And so it doesn't know what to do when you use Q for an integer. And so it just crashes. So these are the kinds of things that you would have to think about. What if the user doesn't follow my directions? Okay, it generates a runtime error. Okay, now that I know that if I could go and modify my program to account for if the user puts in some bad things that aren't integers between 1 and 100, then I should give them a message and say, you know, something polite like, I'm sorry, you entered an invalid number. Please, you know, follow the directions and put in an actual integer between 1 and 100. So you can deal with that gracefully, but of course you have to first realize that that's going to happen. And that way, so that's an example of a runtime error and how the process that you might go through to try to detect those errors and then fix them. Okay. And then we have semantic errors. Those are usually the most difficult to correct because your program doesn't crash, right? It runs, but it just gives you something bad. And so you don't really know what line it happened on. You know, notice with the runtime error here, it told me that it happened on line 9. So I know that it crashed when it got to line 9, and I can go look at line 9 and figure out what happened. But with a semantic error, where your program doesn't crash, but you just get these bad results, you have no idea like what line to go or where to go look for it. So that's why it tends to be the most difficult to correct. And you just have to go through basically every line. Does this really, what does this actually do? And you have to, you know, just step by step go through and figure out exactly what the program is doing. There also are tools called debuggers, and we'll learn how to use the debugger to help us step through and see what the program is doing and what you're expecting to happen and then what it's actually doing. And so our semantic errors are going to be the ones that give us the most problems. Okay, one last thing that we want to talk about to finish up chapter 1 is the difference between formal and natural languages. And so we have natural language are languages that people speak, like English or French or Spanish or Chinese. And these are not designed by people. Formal languages, on the other hand, are languages that are designed by people for a specific purpose. So, like, as you've taken math courses throughout your life, you have learned a formal language, or at least many parts of a formal language that mathematicians use to denote relationships among numbers. So if you or a mathematician were to look at this statement here, okay, it looks kind of like a bunch of crazy symbols, but a mathematician, and maybe even you, know what this means. If you were to look look at this, you might say, oh, that's just the definition of the binomial theorem. Okay, this just means if I take one value this plus another value, or the sum of two values, and raise that sum to the nth power, then that would just be the sum of all of the values, okay, that would be n choose k times x to the k times a to the n minus k, where k can vary from 0 to n, and I would just add those all up. So all these symbols mean something, and these are all part of this language so that I can easily and concisely represent a mathematical concept. Maybe you've also taken a chemistry course. Chemists use a formal language to represent the chemical structures of molecules and to represent what happens in chemical reactions. So if you were to look at this, you might say, oh, we've got 2 molecules of C2H6 plus 7 molecules of oxygen, O2, and when you put those together, you will get a chemical reaction that will produce 4 molecules of carbon dioxide and 6 molecules of water. Okay, so that's what all of that means, and if you were a chemist, you would look at that and it would make perfect sense. So every formal language has a strict syntax. So mathematics has a strict syntax. Chemistry language has a strict syntax, and those are just the rules that have to be followed to create well-formed statements. So you can't take this number 2 and put it at the end and know what that would be meaningless. It would not have a correct syntax in chemistry. Okay, if you know, let's see, what could we do to this math one to ruin the syntax? So you can't put, you can't leave off, if you put, this n as a subscript instead, it would not be correct syntax. It wouldn't mean the right thing. That would be a subscript. It wouldn't be an exponent. Okay, so the syntax means something particular in each language. Now there are actually 2 kinds of syntax errors or syntax rules that you can make. One of them is about tokens, okay, and one of them is about structure. So both of these are, if you make an error in tokens, that's a syntax error. If you make an error in structure, that's also a syntax error. So tokens are all the basic elements that make up the language. So in math, you can have symbols and you can have numbers. Okay, those symbols can be operators or things. Okay, and they have to, so those are the things that you can put. Those are all the tokens that are legal in math. In chemistry, you can have numbers and you can have letters or combination of letters that represent elements from the periodic table. But you can't have some letter in here that doesn't represent an actual element from the periodic table. Okay. So those are what the basic elements are. Like if we were thinking about the tokens in the English language, it would be words and punctuation. Those are the things, you can take words and punctuation and string those together in certain ways to make legal sentences or legal statements in the English language. Okay, so we have tokens, but then we do have to string them together to make a statement, and that also must be done in a certain way. That's the idea of structure. So that's how the tokens are arranged together or strung together to make a correct kind of a statement. Okay, so you can't just take words and punctuation and just randomly put them however you want them and then expect that to be an English sentence, right? The structure, there's rules about, you have to have a subject followed by a predicate. Okay, you're at the beginning, you have to have a capital letter. At the end, you have to have some kind of a punctuation that is a legal end mark. So it could be a period, or it can be a question mark, or it can be an exclamation point. So you have these rules about how to make legal sentences, and that must follow that structure. or it's not correct. Okay, so let's look at a couple examples to help us get this idea be error in tokens or an error in structure. So this is an exercise from your book. We'll just do it together. Write a well-structured English sentence, but it has invalid tokens in it. Okay, so this might be an example I could do. Okay, the KNGHT mounted his horse. Okay, now clearly I've probably made a spelling error here. I meant to put the knight mounted his horse, but I forgot the I. Okay, and so this has the right structure. Okay, it's got the subject first, and then it has the predicate, and then it's got a direct object. So, you know, it follows the structure of correctly, but it's got this invalid token in it. Okay, there's no such thing as a KNGHT. What is that? That's nothing in English. So this would be an error in token. This is an invalid token. So a spelling error would be an example of, you know, an invalid token. So if you're using a word processor can find these token errors for you. Okay, another thing that would have an invalid token is if you use like a bad operator at the end. So if I used, you know, like a comma at the end. Okay, that would, so this, well, I guess that would be an invalid structure as well. So, because part of your structure is you have to have a legal end mark on there. All right, so let's do another sentence that has all valid tokens, but it has an invalid structure. So let's say I fixed my spelling error, and I turn this into knight, but I have something like mounted horse is knight. Okay, so every single one of these words is completely illegal. Wait, it should have been legal. Are completely illegal tokens in English. Okay, but the structure is all wrong. I'm supposed to have a subject and then a predicate, like mounted horse. You know, mounted, that's the verb, that comes first. And then I've got stuff here, and I can't even tell what this is supposed to be. So I've got legal tokens, but it's just not structured well so that it's an understandable English sentence. Okay, so that's the difference between tokens and structure. And you have to have both correct tokens and correct structure for the syntax to be correct. And that leads us sort of to our final question we want to address, and like, why do we have to learn a language like Python to program a computer? Why can't we just write a program in English? So why don't we program in natural languages? Why, it would be so much easier if I could just write a program in English, and somebody who spoke German could write their program in German. So there is a big difficulty with natural languages. So we've talked about syntax, and that's basically what a statement looks like. Okay, so the structure in particular is what it looks like, how it's arranged. And syntactically, we can probably come up with a pretty good way of taking a natural language and checking the syntax. So that's what a lot of word processors do, right? If you're typing a paper, it'll tell you if your subject and verb disagree, or it will find capitalization errors and spelling errors and lots of those things for you. So it can do a pretty good job of checking syntax. It's way more difficult to check the syntax of English, and you've probably made some kinds of errors, and your word processing program didn't find them. Okay, so you can kind of do a decent job of checking the syntax for natural languages like English, but it's the semantics that really get us. So semantics are what a statement means. So you remember our semantic errors. So you thought you solved the problem and it does something different than what you wrote. Okay, because statements can mean different things. So if you think about English, there's a lot of ambiguity in English words. Like a lot of words can be used as nouns or as verbs. They can be used, there's other, depending on the placement of the word, of a pronoun, it might mean something different. It's all because of the context. And so there's a lot of ambiguity in natural languages, and to deal with this ambiguity, we often have to employ certain kinds of redundancy in natural language. And so we have to use a lot of words to actually say what we want to say without being ambiguous. So often natural language can be very verbose. The other thing that causes a lot of trouble is idioms and metaphors. And so I might say, oh, it's raining cats and dogs, and you know what that means, but it's very difficult. Like, I don't know, that you maybe have seen, YouTube videos or something of AIs that they're trying to train to understand natural language, and it's very difficult for like a robot to understand these kinds of idioms. Like, what does it mean to rain cats and dogs? I look out the window, there's no cats and dogs falling from the sky. So it's very difficult to understand like that phrase means something completely different. It's not literal. Okay, so all of these things make it very difficult to process natural language. Okay, that's why there's a lot of AI projects out there, artificial intelligence projects, where they try to build, computers, programs that can actually understand English language. And it's getting better and better, but still it's very difficult. And so it's not very easy to program in a natural language. Formal languages, on the other hand, there's never any ambiguity. So whatever word you put in a program always means the same thing. It never means something different. Okay, because there's no ambiguity, they are often very concise. So they're much shorter. What you might have to write in English could take 1/6 the amount in a programming language, because it's always it's never ambiguous. And formal languages are always literal. They always mean exactly what they say. Okay, so when I see a statement, it always means the same thing, and it literally means exactly what it says. It couldn't ever mean anything else. And so it's much easier to write something like a compiler or an interpreter to be able to actually do what the program says, because of these characteristics of a formal language, being not ambiguous, being concise, and being literal. Okay, so that wraps up chapter 1, and next time we're actually going to look a little bit more at the fact that machines can only understand binary, ones and zeros. So how can we take the things that we need to work with, any kind of data, and represent that as binary numbers? So how do machines actually take binary strings of ones and zeros and do something meaningful with it? So we'll look at that just briefly, and then we will get into starting to write some Python programs.